Hello my dear students, how are you all? Welcome to our YouTube channel Diksha Karnataka. I am Ankit Srivastava bringing you another very important session for our series 60 out of 60 in KCET Maths in 100 days. Okay, today we're going to talk about multiplication of matrices and transpose of matrices. Okay, again a simple topic, but people make a lot of mistakes in this because this gets lengthier, right? So we'll try to keep it as simple as possible and solve good amount of questions on those topics. Transpose is relatively easier than matrices multiplication. I hope I will be able to clear all of our doubts in the session today, and we'll complete our multiplication of matrices and the properties. Again, same thing with transpose and properties. So without wasting any time, take out your pen and paper and let's start with the session. Okay, let's begin. All right, sir. So before moving forward, let's recap what we have learned so far in matrices. So we have learned the definitions, right? And we have also learned the types of matrices. What we have learned is, first thing that we have learned is the definition of matrix. In this we talked about it is a rectangular arrangement or array where we put data and function in it, okay, which is very helpful to perform a lot of complicated calculations when other types of or other mathematical operation is not able to solve those questions. Matrices helps us solve those functions and data points by arranging it in array. Okay, now we also learned about the types of matrices, right? Null matrix, upper triangular matrix, lower triangular matrix, identity matrix. Also we learned about the order of the matrix, right? When can we call a matrix a square matrix, rectangular matrix, diagonal matrix? So all these definitions are covered in my previous sessions. Make sure that you go and watch it if you have having any doubt. Okay, so get your fundamentals clear, then you can come back and see this video for your matrix multiplication and transpose. Okay, so we have learned the definition of the matrix. Second, what we learned, bacha, so we also learned, as I said, types of matrices. Okay, then we have learned in the previous session, what was it? Operations on again same thing, matrices. What type of operations we learned? We learned three such operations. First one was addition. Second was subtraction, and third was a multiplication only, but what kind? Scalar multiplication. It was scalar multiplication. So we have done till this part, okay, and we have solved questions on all of these categories. So we have solved questions on all these categories, right? We have solved questions on all these categories of various kind. Okay, starting from simpler questions to moderate and difficult, all of these I have included in the session. So I hope you have learned from them. If not, then go and watch the videos and make sure that you are complete with the previous two sessions before starting this one, which is matrices part 3, where we will talk about matrix multiplication. So the principle of the matrix multiplication is the same. Okay, what we do is for it to be multiplied, the required condition is very simple. The number of columns in matrix A, if we are trying to multiply what? A and B. So the number of columns in A should be same as number of rows in B, right? Number of rows in B. Does it make sense to you? For example, if I'm writing, let's say, order, just the order for my matrix A, and let's call it to be m cross n. And I have order of matrix B as, let's call it to be n cross p. Whenever this condition is satisfied, means you can check here, n means what is this? N represents, it's column, no? It represents column, right? And what does this represents? Row, right? It's row only. Check number of columns in A. How much is that? Sir, it is n. Great. Is equal to number of rows in B. How much is that? It's n. So whenever this condition is satisfied, then only matrix multiplication is possible. How will that be done? We'll see later. But first of all, the very primary condition is this has to be true. Means the number of columns here, n and n, the number of rows has to be equal. And if I do that, let's say if I do that and I get a matrix C which is equivalent to AB, which is equivalent to AB, means after multiplication of A and B matrix, I get a matrix C. Then the order of matrix C, then the order of C would be what? Would be what, bacha? So wherever you see, so the common part will become, or will cancel each other, and what you'll have? You'll have M cross P as the order. You'll have M cross P as the order. So does it actually cancel? No, it doesn't cancel, but when you multiply it, what you'll get the result, no, will look like the order of M cross B. Okay? If this is not equal, multiplication is not possible, but if it is equal, if you multiply the two matrices A and B and the resulting matrix is C, then the order of the matrix C would be M cross P. M cross P. Check here. Please check here. M cross P. I'm talking about these two combinations. M cross P. Okay, sir. Now always remember, matrix multiplication is done from where to where? Only this way. Row to column. Row to column means the first matrix that you have taken. So let's say you have taken A times B. We are trying to multiply A and B, matrix A and B. Then you will take row of this and multiply column of this. You'll take row of this and multiply column of this, one at a time. Okay, one at a time. When you do that, the result will be what? The result will be what? So that will lead to the first row. Okay, we'll see in the example. We have taken example when the order has to be, the number of rows and column has to be the same, and how this will work. Just remember this thing. Only this condition has to be there. There's no other way to multiply matrix. Only row of the first matrix are multiplied with column of the second matrix. I hope this is clear. Okay, sir. Okay, what is this? Whenever you are multiplying, let's say a matrix is multiplied to itself, means A is multiplied to A, called as square, right? So A into A is equal to A square, no? Whenever A into A, which is nothing but A square, whenever that is equal to A, then the matrix is called as idempotent matrix. Idempotent matrix. When is this case? Only if the matrix multiplied to itself gives a matrix itself. Matrix multiplied to itself, A times A, giving the matrix itself. A times A giving the matrix itself. Basically what? A square is giving A. When this condition is satisfied, we'll call it to be idempotent matrix. What do we call? The matrix A to be idempotent matrix. I hope this is clear. Okay, let's see some example. Okay, so here one example is there. If I have to ask what is the order of A, what is the order of matrix A? So there is only one row. Yes, there's only one row and column is 3, sir. Column is 3, sir. It means basically what is the order, bacha? A is 1 cross 3, sir. A is 1 cross 3, sir. Serious, right? One row, 3 columns. One row, 3 columns. When that is the case, order is 1 cross 3. M is 1, N is 3. What about B, sir? Sir, B, it has only one column, but rows are 3, sir. 1, 2, and 3. So basically rows are 3 and column is 1. Rows are 3 and column is 1. Rows are 3 and column is 1. Now check here carefully. When I am trying to multiply A and B, what did I say? M cross N and N cross P. Means these two has to be equal. N and N has to be equal. Check here please. So N is 3 here and N also here is 3. Means the number of columns in the matrix A is equal to what, bacha? Number of rows in the matrix B. Correct? Number of columns is 3, sir. The number of rows is 3, sir. So number of columns in matrix A is equal to number of rows in matrix B. So yes, sir, we can do the multiplication. How? As I said, you'll take the matrix here. Row, first one will take row, second one column. Why, sir? Because multiplication is always what? Row to column. Multiplication is always row to column, okay, in the matrix. So check here. So row is taken here. There's only one row, so I've taken here, and there's only one column, so I've taken it like this. Okay, only one row, right? Only one row and only one column. So it's taken like this. If it was more, we'll see a case where there is more than one row and column. But for now, only one row and one column. Okay. And before doing the multiplication, let's talk about. Let's say let's say after multiplying the matrix A and B, this is equal to matrix C. Okay, let me take another name. Let's say after multiplying matrix A and B, the result is equal to matrix X. Matrix X. Now I'm asking you, what is the order of the matrix X? I'm asking you, what is the order of the matrix X? So what did I say? Club M and P together. Club M and P together, neglecting A. So what is M here? M is 1, sir. And what is P here? 1, sir. What's the order then? 1 cross 1. Okay, 1 cross 1. What is the order then? 1 cross 1. Check here. The result that I'm getting, this is nothing but my matrix X. What's the order? 1 cross 1 only, no? What's the order here? 1 cross 1. How, sir? Only one row, only one column, because there's only one element, no? Excuse me. How many rows? How many rows? Sir, only one. How many columns? Sir, only one. Correct? So that thing we learned, that whenever we are multiplying two matrices, the order of the resulting matrix is written like this: M cross P, M cross P. So M is 1, P is 1. Okay, sir. Let's see the multiplication. So what you're going to do is, after taking row and column together, so first row and first column. In this case, only row and only column. Okay. So you'll multiply the respective elements. You'll multiply the respective elements. So see, 1 times 5. 1 times 5. Okay. Then you'll have to add this. You have to add this with 3 times of minus 4. 3 times of minus 4. 3 times of minus 4. See. Then again, add it with minus 4 times of minus 2. Minus 4 times of minus 2. If you do that, what are you going to get? 1 times of 5 is 5. 3 times of minus 4 is minus 12. 4 times of 2 is 8, and minus becomes positive. So plus 8. 5 plus 8 is 13. Minus 12 is 1. So answer is 1. Answer is 1. Okay. Alright. So they are saying in this case, BA is also defined. Why BA is defined, sir? Why is BA defined, sir? Let's see. If I write B first. If I write B first, which is 5 minus 4 and minus 2. Okay. So what is the order here? 3 cross 1. 3 cross 1. Okay. And what about A, sir? If I write A will be 1, 3 and minus 4. 1, 3 and minus 4. How much is that? What is the order of this? 1 cross 3. 1 cross 3. 1 cross 3. Now check here carefully. Check here carefully. 5 minus 4 minus 2. Correct? 1, 3 minus 4. 1, 3 minus 4. Now if you check, the number of columns here is 1 and number of rows here is 1. Number of rows here is 1. Means they are equal. So if this is equal, means we can do the multiplication. And if the result of B times A is equal to what? Is equal to what? Y. Is it equal to Y? Then order of Y will be how much? 3 cross 3. 3 cross 3. 3 cross 3. Let's check. We'll multiply B and A also, and let's see how it is coming as 3 cross 3. Okay. Let me write it over here. So let's check. We are looking to find what here? Looking to find BA. Okay. How does that look like? What is my B? B is 5 minus 4 minus 2. B is 5 minus 4 minus 2. 5 minus 4 minus 2. And what is my A? A is 1, 3 minus 4. A is 1, 3 minus 4. 1, 3 minus 4. Okay. Let's do it. So what is the order? Order we know. Okay. How many rows and columns here? How many rows and columns? So there are 3 rows here and 3 columns here. So at least this much we know, that the resulting matrix will have how much? The resulting matrix will be 3 cross 3. This we know. 3 cross 3. It means I will have a square matrix. I will have a square matrix that will look like this. Correct? Let's check. So first I will multiply what? Row 1. This with the column 1. How much that is? 5 into 1. 5 into 1. Next I will do what? Same thing with this row with column. So 5 into 3. Similarly 5 into minus 4. Okay. Again minus 4 into 1. Row 2 I am doing with column 1. Again I am taking what? Row first, column next. So minus 4 times of 1, minus 4 times of 3, and minus 4 times of minus 4. What about this? Minus 2 times of 1, minus 2 times of 1, and minus 2 times of 3, minus 2 times of minus 4, minus 2 times of minus 4. What is the result of BA? The result of, forgive me, the result of BA is nothing but 5, sorry, yes sir, let's continue. So 5, 15 minus 20 minus 4 minus 12, 4 times 3 is 12, negative sign, minus 4 into minus 4 is plus 16, minus this is 1, so minus 2 into 1 is minus 2, minus 6 here, and plus or just 8. This is my answer. What is the order here? 3 cross 3. The order is 3 cross 3. 3 cross 3. Now if I take another example to say or to give you where we have more than one row and one column like this. So let's take a simpler example. Let's take when A is equal to 2 1 0 2 and B is equal to 1 3 3 1, 1 3 3 1, or you can take something different also. Okay, 1 3 2 1, 1 3 2 1. Let's do the multiplication of AB. Is it possible the multiplication of AB? Check the matrix order. 2 cross 2 here, and here also 2 cross 2, here also 2 cross 2. Yes sir, this and this is equal, so I can do the multiplication. The number of columns in the first matrix is equal to number of rows in the second matrix. So yes, multiplication is possible sir. Okay, let's check quickly. How will I do this? So first I will take what, bacha? First I will take what? First I will take this row and I multiply with this column. First one first. So how will I do that? 2 times of 1. I said na, corresponding element we do 2 times of 1. So 2 times of 1, okay, plus 1 time of 2. 1 time of 2. Why 1 sir? Second element of the row 1 with second element of the column 1. So plus 1 time of 2. The sign will be plus in between. Next we'll move on to row 1, column 2. Remember, row 1 with column 1, okay, with the both elements, corresponding elements with a plus sign, and then row 1 with column 2. Row 1 with column 2. What is that? Column 2 is now here. Column 2 is now here. Okay, so row 1 with column 2. If I do that, how will it look like? 2 times of 3 will be 6, and 1 time of 1 will be 1, right? What I'm doing is, if I have to write in the expanded form, I can write like this. 2 times of 3 plus 1 time of 1. So first two elements I've got. What about this one? Again, in this case, I will take second row with the first column, second row with the first column. How will that look like? So 0 times 1, corresponding element 0 times 1 plus 2 times second element of the second row is 2, and second element of the first column is 2. So 2 times of 2. Then again what? Second row with second column. So 0 times of 3 and 2 times of 1 plus 2 times of 1. Simplify this AB. This will look like 2 times 1 is 2 plus 1 times 2 is 2, so 4. 6 plus 1, so 7. This is 0, this is 4, so just 4. And what about this? 0 plus 2, so 0 plus 2. Answer is 4742. 4742. What is the order? Order is 2 cross 2. How sir? See, if m cross n and n cross p is there, the remaining is 2 cross 2 only, so m cross p. I hope this is clear. I hope the metric multiplication is clear, whether it is 1 cross 3, 3 cross 1. I've taken the different cases here. Okay, the result was 3 cross 3 here, and the result is 2 cross 2 here. Okay, let's move on to the properties. Okay, the most fundamental property that we know is this one, commutative property. What is it? Commutative property. This is not valid, bacha. This is not valid all the time. So AB might not be equal to BA. Not always. It can be equal also, but it might not be. So usually what we used to do, remember, if we are saying that, sir, 2 into 3 is equal to 3 into 2, na? 2 into 3 is equal to 3 into 2. So 2 into 3 is 6, sir. 3 into 2 is also 6. So they are equal, sir. They are equal. But what happens is, in case of matrix, the order might change, right? order might change. So the multiplication will not be same. The multiplication will not be same, and the element also position will change, right? Element position will change, sign will be different. So AB might not be equal to BA in the case of matrix multiplication. In the case of matrix multiplication, it is equal. Yes, multiplication is commutative when we are doing with just numbers, okay? But in the case of matrix, it is not always commutative. It's not always commutative, okay? It may be commutative, but not always, okay? Moving on. But it is associative. It is associative, means if I multiply A and B first and then multiply C to it, okay, that will give me the same result as if I multiply B and C first and then we multiply A to it. So if I multiply A and B first and then we multiply C to it, or I can do other way around. A I'll keep as it is, multiply B and C together and then multiply A at the last, will give me the same result. I hope this is clear. So yes, matrix multiplication is associative in nature. Also it works on distributive law. It means if I'm using addition and multiplication like this, A times of B plus C, A times of B plus C, then yes, it is true. A times of B plus C is correct. I can do A, first I add the two matrices and multiply with it. First I add the matrix B plus C and multiply A with it, or I multiply AB and AC together and then give the addition. That also will give me same result. If I do the addition first and then multiply, it gives me same result as first multiplication then adding the results, okay? Works other way around also. First we add the first two elements or first two matrices and then we multiply with C, or AC plus BC is also correct. AC plus BC is also correct. So distributive law over the addition works for and is valid for matrix multiplication. Okay. Property number 4. Okay. Means even though we have, let's say, having two matrix A and B, I have two matrix A and B which is not equal to null matrix. So I have matrix A and matrix B is not equal to null matrix. What is null matrix, sir? Null matrix means all the elements are 0, nothing is there. So if I'm writing like this, let's say AB, if I writing AB may be equal to null matrix. Okay, even though A and B individually, they are none of these two elements, none of these two matrices are null matrix, the product of the matrices might be a null matrix. We'll see examples on this, not a problem. We'll see examples on this. So I've taken questions on this where we will be solving or understanding and using this property. Okay, so product of two matrices can be null matrix, even though neither of them is null matrix. I hope this is clear. Okay, next property. Okay, so if I have A as a given square matrix, then I is, what is I? I is the identity matrix, right, of the same order, and obviously A into I is same as I into A. Why is that, sir? Because we know I is also called as identity or unit matrix. So just what is I? I is like this, no, 1 1 0 0, or what is it? 1 1 1 0 0 0 0 0 0. So if you multiply this matrix, which is I matrix of order 3, with any rectangular, any square matrix with order 3, then the result will remain same. So IA or AI will give me just A only, Again, we will use this in our conditions. Okay, you will in the questions we are solving in the coming classes, we will use this property. Okay, property 6. If A is given square matrix, and what is 0? 0 is the null matrix, right? This is how we represent. I can write 0 as 0 or 0 as m cross n. Okay, m cross n. I can write null matrix as just 0 or 0 m cross n. Same order is A, then 0 into A or A into 0 will give me 0 only. Okay, so if you multiply null matrix to any square matrix, the result is 0. Okay, sir, or the null matrix itself. Moving on, the first question is worked on what? It is what, bacha? Distributive law, no? A times B plus C is equal to AB plus AC. This is distributive law. So we will try to solve the RHS part first. We'll find AB and AC first, and then we'll go, we'll add them, and then we'll see whether it is equal to A times B plus C or not. We have the matrix. Let's see if the multiplication is possible or not. First thing, we'll check whether the multiplication is possible or not. How do we do that, sir? So this is 2 row and column is 3. 2 row and column is 3. Okay, sir. What about this? This is 3 cross 3, sir. 3 cross 3. Yes, then we can multiply, no? This 3 and this 3 is equals, we can multiply. What about C? This is nothing but again 3 cross 3. So yes, we can multiply A to C also. So yes, even AB is true and AC is true. Okay, what about B and C? Can we add B and C? Yes, sir. B and C both are 3 cross 3. So to add a matrix, or when we can say that a matrix is conformable for addition, only when the order of the matrix is equal. Remember this. When can we say two matrices are conformable for addition? Whenever they have same order. So we can add B and C because matrix is 3 cross 3 for both of these. Okay, the order is 3 cross 3 for both of these. Alright, sir. So let's take the RHS part. Let's take the RHS part first. So I'm gonna do it here only. So we are doing with AB. First, let's try with AB. Multiplication of AB. So what is A gonna look like? Check here. So obviously, what is the result of AB? It will be 2 cross 3 only, because 3 and 3 is common. And what is the result? 2 cross 3. See, this will remain with this. So 2 cross 3. Okay. AB will be 2 cross 3 only. Okay, sir. Okay, sir. Great. So if I do that, what is my multiplication looking like? Check. Check. Okay. Please cross check the multiplication. I might make some calculation mistake, but I'll try not to. Okay. Chaliye. So first thing, what do? We take the first row and multiply with first column. Okay. Let's see how it looks like. First row will be 2 times of first corresponding elements will you take in the row and column. Yes, first row to column, but what next? The corresponding element. So 2 times 0, 1 times 2, 0 times 1. So what is it? 2 times 0, 1 times plus 1 times. For the first multiplication, I'll write everything, then I'll write directly. Okay, I hope you understand. So 2 times 0, then 1 times 2, 1 times 2 plus 0 times 1. See, 0 times 1. So 0 times 1. This is my first one. Second one will be what? Same row with the second column. Same row with the second column. Now this column will come. Okay. So 2 times 2 will be just 4. Will I be able to write this here? I don't think so, because the space is not enough. So let me write it here. AB. Okay. AB. I'll take the result from here directly. 2 cross 0 will be 0. 0 plus 2 plus 0. 0 plus 2 plus 0. Correct, na? 0 plus 2 plus 0. Okay, sir. What about second element? Of this matrix AB? Sir, they will take this first row of A and second row of column. Sorry, first row of A and second column of B. Okay, so it will be 2 times 2. This 2 times 2. How much will that be? 4. Then 1 times 0 will be just 0. Then 0 times 1 minus 1 will be again just 0. Okay, sir. Great, bacha. Moving on. Same row, 1 with third column. So 2 times 3 will be 6. 2 times 3 will be 6. 1 times 1 will be 1. And 0 times 4 will be 0. Okay. So first row of matrix AB is done. Moving on to second row. Now we'll move on to the second row. Where is second row, sir? Second row is here. I hope you can see that. Okay. So let's use it. Okay. So minus 3 times 0, right? Because same thing. We did first row with first, second and third column to get the 3 elements like this. Correct? Same way we have to do second row for the all 3 columns. So second row with the first column. Minus 3 times 0 will be 0. Minus 3 times 0 is 0. 0 times 2 will be 0 times 2 is 0, sir. 5 times 1 is just 5, sir. Okay, bacha. What about my second row with second column? So minus 3 times 2. How much is that? Minus 6, sir. Okay. 0 times 0, sir, 0. What about 5 times minus 1? Sir, minus 5. 5 times of minus 1 is minus 5. Okay, sir. Now what is left? Second row with third column. So minus 3 times of 3. How much is that, bacha? Minus 9. 0 times of 1. Sir, 0. And 5 times of 4, sir, 20. Sir, 20. Okay. What is AB now coming as? Check, AB is coming as what? I can write it here also. I can write AB just here. Okay. So this will be looking like, first element will be 2, 4 and 7. Check here. 2 plus 0 is 2. 4 plus 0 is just 4. 6 plus 1 is 7. So 2, 4, 7. So first row is 2, 4 and 7. This clear? 2, 4, 7 is clear. Next, 5 minus 6 minus 5 plus 0, 0 is 5. Minus 6 minus 5 minus 11. So 5 minus 11 and 20 minus 9. 0 is just 0. 20 minus 9 is 11. So answer is what? 5 minus 11 plus 11. Check here. Please check calculations. 5 minus 11 plus 11. If you are not sure with my calculation, make sure that you solve it and get the same result. Okay. I hope you'll get the same result. So 5 minus 11 plus 11. Okay. AB is done. Same thing we'll do with what, bacha? Now BA. Same thing we'll do with BA now. No. Sorry. Not BA. Pardon me. Forgive me. AC. Same thing I'll do with AC. AB I got. I need AC again. So I'll write for AC. So just bear with me. The session will be longer. You know that matrix multiplication takes time. Okay. In the exams, the question might be given which is not requiring that much of multiplication. But if you are learning the multiplication, if you are learning the concept, then yes, it will take some time, bacha. Okay. So let's do AC first. Again, we'll do the same principle. We'll apply the same principle. Okay. Okay. So AB is so done. AB is so done. What about AC? Can we do the multiplication? Yes, sir. 2 cross 3, 3 cross 3. We can do it. So again we'll do what? Again we'll do what? First row of A with first column of C. First row of A with first column of C. How will that look like? So 2 times of minus 1. So 2 times of minus 1 is how much? Minus 2, right? I can write directly, no? Minus 2, right? 2 times of minus 1 is minus 2. Then second element is 1 times of 1, which is plus 1. See, first row with first column, corresponding elements. Minus 2 times of minus 1, 1 times of 1. Then 0 times of 2, which is just 0. This 0 times of this 2, so just 0. Okay, sir. Now, is it done? This is the first element done. Now we have to do first row with second column. First row with second column. How will that look like? So 2 times of 0, 0. 1 time of 3, so plus 3. 0 times of minus 1, so what? Just 0. Okay, so this is also done. Okay, next what? First row with third column. Third column. So 2 times of 2, what is it? 4. 1 time of 1, so just 1. And 0 times of 1, so just 0. Just 0. Okay, sir. What about next? We'll do the same thing with second row. So minus 3 times of minus 1 will be 3. 0 times of 1 will be 0. And 5 times of 2 will be 10. Correct, right? 5 times of 2 is 10. Next what? Second row, second column. So minus 3 times of 0 will be 0. 0 times of 3 will be 0. And 5 times of minus 1 will be minus 5. 5 times of minus 1 will be minus 5. Okay. Again second row with third column. So minus 3 times of 2, minus 6, minus 6. 0 times of 1, just 0. And 5 times of 1, just 5. Just 5. Just 5. Okay. I hope this part is clear. I know it's taking time. But we have to do it, right? It's taking time, but we have to do it, and we have to make sure that it is correct. Okay. Okay. All right, sir. Now AB and AC I've got. AB and AC I've got. Okay. I have to simplify AC first. AC will look like same. 2 cross 3 only. So check here. First element. Minus 2 plus 1 is just minus 1. Minus 2 plus 1 is just minus 1. 0 plus 3 plus 0, 3. 4 plus 1 is 5. Next what? 3 plus 0 plus 10, 13. 3 plus 0 plus 10. 3 plus 0 plus 10. Okay, 13. Next what? 0 plus 0 minus 5. So minus 5. Minus 6 plus 5. So minus 1. This is my AB plus AB and AC. Now we have to do AB plus AC. Let's do that here only. AB plus AC. AB plus AC will look like what, bacha? So we have to add the corresponding elements. We can add it, right? Because both the matrix are having the same order. What's the order of the matrix in both the cases? Same, 2 cross 2 and 2 cross 2. 2 cross 2 and not 2. 2 cross 3 and 2 cross 3. Number of rows are 2, number of column is 3. Okay, let's add them. So AB plus AC will look like this. 2 plus minus 1. 2 plus minus 1. So just 1. 4 plus 3. So 7. 7 plus 5. So 12. 5 plus 13. So 18. Minus 5 plus 1. Minus 5 minus 11. Sorry, it looks bad. This is minus 11, right? That's minus 11. That's minus 11. Okay. So minus 5 minus 11 is minus 16, and 11 minus 1 is 10. This is my AB plus AC. This is my AB plus AC. Okay. Now moving on to so this is my RHS. This entire thing was my what? This entire thing was my RHS. I hope you understand that. This was my RHS. Okay, my RHS. I got AB plus AC, my RHS. Now I have to do what? Add B and C, then multiply with A. Add B and C, then multiply with A. Okay. So if I have to add a B and C, can I do it here only? Can I do B and C over here only? Will be easier for us. B plus C. We are trying to do what? B plus C. So what is the order of B plus C? 3 cross 3. Both of these are 3 cross 3. Both of these are 3 cross 3. Check here. 3 cross 3, 3 cross 3. So I can add it quickly. Check here. First element. 0 with minus 1. I hope this is visible. 0 with minus 1. So minus 1. 2 with 0. So how much is that? Just 2. 3 with 2. So how much is that? 5. 3 with 2 is 5. Again now over here. 1 with 2. So 3. 1 with this 2 is 3. 3 with 0. 3 with 0 is 3. 1 with 1. How much is that? 2. Okay, next what? This 2 with this 1. How much is that? 3. Check here. Minus 1 with minus 1. How much is that? Minus 2. 1 with 4. How much is that? 5. Check B plus C. Please check B plus C. Please check B plus C. So minus 1, 2, 5. Over here. Minus 1 plus 0. Minus 1, 0 plus 2. 2. 2 plus 3. 5. 1 plus 2. 3. 3 plus 0. 3. 1 plus 1. 2. 2 plus 1. 3. Minus 1, minus 1, minus 2. 1, 4, 5. So B plus C we have got. So we'll write B plus C on the next slide. We'll write B plus C on the next slide. Okay. What is the matrix looking like? 3 cross 3. Answer, let me write it quickly. Minus 1, 2, 5. Minus 1, 2, 5. So first row. 3, 3, 2. 3, 3, 2. 3, 3, 2. Next is what? 3 minus 2, 5. Next is what? 3 minus 2, 5. 3 minus 2, 5. What else? What else we need? We need A, because we have to multiply A with B plus C. What is A? 2, 1, 0, 3 minus 3, 0, 5. What is my A? A is 2, 1, 0 minus 3 minus 3, 0, 5. Minus 3, 0, 5. What is the LHS part? What is my LHS? A times of B plus C. A times of B plus C. Okay, sir. So again we'll do what? We will take first row over here and multiply with all these columns one by one. One by one. Let's check. Let's check. So let's check the order ones. So this is 2 cross 3 and this is 3 cross 3. So I can do that, right? I can do that. So if I do that, 2 times of minus 1 will be how much, bacha? 2 times of minus 1 is minus 2. 1 time of 3 is 3. 1 time of 3 is 3. And 0 time of 3 is just 0. Okay, sir. What about next? 2 times of 2, 4. 1 time of 3, 3. 0 times of minus 2, just 0. Next what? 2 times of 5, so 10. 1 time of 2, so just 2. And 0 time of 5, so 0. Okay, check here. Please check here. 2 times of 5, 10. 1 times of 2, just 2. 0 times of 5 is 0. What is this next part? I'll take the same thing with second row. Second row. Minus 3 times of minus 1. So plus 3. okay, minus 0 times of 3 is just 0, and 5 times of 3 is 15. Okay, quickly check here. Minus 3 times of minus 2, minus 6, 0 times of 3, 0, 5 times of minus 2, minus 10, and again here minus 3 times of minus 5 is the third row, minus 15, 0 times of 2 is 0, and 5 times of 5 is 25 plus 25. Okay, plus 25. Let's check the result. Simplify it. This is 1, minus 2 plus 3 is 1, 4 plus 3 is 7, 10 plus 2 is 12, 15 plus 3 is 18, minus 6 minus 10 is minus 16, and 25 minus 15 is minus or plus 10. Check. This is my LHS. 1, 7, 12, 18 minus 16 plus 10. 1, 7, 12, 18 minus 16 plus 10. Check here. 1, 7, 12, 18 minus 16 plus 10. Okay, I know it took time, but we got the right result. So LHS equals to RHS. So we have verified what? The given statement, this. Okay, AB plus AC equals to A times of B plus C. The distributive law is verified. I hope this is clear. This is clear, right? Okay, moving on. Okay, now this positive multiplication with itself. So if you take the positive integrals, if you take positive integral or the powers for square matrix, the matrix what? The order, this matrix A is a square matrix. This matrix A is a square matrix, and if you multiply with itself, so A times 1 will be just A square will be A times A cube will be A square times A, which is A into A into A. So basically the property of exponent will be valid here. Check here. If I am doing n plus 1, I can write it as A power n times of A, okay, or A times of A power n, okay. Alright, so basically this part is valid for natural number when n is the power is natural number. Why natural number, sir? Look at here, positive integrals. Check here, positive integral power. What it means? Natural number, no? Integers which is positive, natural number. So only if it is natural number, these rules are, or rules of exponent are applicable. So A power m and A power k, A power k can become A power m plus k. A power m into k, again power will be multiplied, where m, k are any two whole numbers. M, k are any two whole numbers. Okay, chaliye. Okay. Alright, this is clear. Very simple. We'll use it in questions, then you'll see. Okay, now simplest question. The previous question took a lot of time. This one will take least amount of time. Okay, let's check. The order of the single matrix. So we have to find the matrix that we are getting from here. Check. This is multiplication. So this is subtraction, right? This is subtraction. Check the sign. Subtraction is a sign. Means order has to be the same. The resulting matrix will have the same order. What is this order? What's this order? This is 2 cross 3. This is also 2 cross 3. The subtraction will be what? This will be again 2 cross 3. What is the multiplying? What we are multiplying with here? We are multiplying it here with, this is nothing but 3 cross 2, correct? 3 rows, 2 column, and this is nothing but, the other matrix is nothing but 2 cross 3. What is my answer? Check, 2 and 2 is common, answer is 3 cross 3. This and this will be clubbed together, so 3 cross 3. Answer is 3 cross 3. Option is D. Option is D. Option is D. Moving on. Okay, now over this one. So A matrix A is a square matrix which is given like this. Okay, they're saying that this is true. They're saying that this is true. Then find K. We can find A square quickly. How will A square look like? A times of A. What does A times of A look like? Write the same odd matrix in this way. 1, 3, 3, 4 multiplied with same thing. 1, 3, 3, 4. 1, 3, 3, 4. Okay, how will I do it, sir? Now I can do it quickly and faster. So same thing, first row, first column, 1 times of 1 plus 3 times of 3, which is 9. 1 times of 3, which is 3, and 3 times of 4 is 12. Okay, check here. So this will be, first is done. 3 times of 1 will be 3, 3 times of 1 will be 3, and 4 times of 3 will be 12. What are you doing, sir? First I did first row with first column and second column. Then I'm doing second row with first column and second column. So 3 times of 1 is 3, 4 times of 3 is 12, 4 times of 3 is 12. Okay, what about next? 3 times of 3 will be 9, 4 times of 4 will be 16. Simplify this. 10, 15, 15, and this is 25, correct? Now they are saying that this is equal to 0, so use this condition here, so a square is this 10, 15, 25, this is my a square, minus ka, so k whatever it is multiplied with every number, so ka will be 1 into k is k, this is just 3k, this is just again 3k, and this is just 4 into k will be what? 4k. Okay, so this part is also done. Now what is next? Minus 5i. So 5i means what? Let me write one step extra without missing anything. So I will look like this. Same order we have to take. Same order. So 0, 0. Why same order, sir? Because we are doing subtraction now, bacha. So the order of the matrix has to be the same all the time. So I has to be 2 cross 2 only. So let's simplify this. Okay, so this will look like 10 minus k. Okay, 10 minus k. First look at the first element. So 10 minus k, and 5 will multiply here. So minus 5. Correct, na? I'll multiply 5 here, will become 5. The sign is negative, so minus 5. Okay, sir. What about next element? 15 minus 3k. And what will this be? 0, because 5 into 0 is 0. So minus 0. I hope you understand. 10 minus k minus 5. 15 minus 3k minus 0. Next about 15 minus 3k minus 0. Again 15 minus 3k minus 0. Why, sir? 15 minus 3k is here and minus 0 is here. Okay, 5 into 0 is 0 only. Next what? 25 minus 4k. 25 minus 4k. Minus 5, because 5 into 1 will become 5. So minus 5. What is the answer? Simplify this, please. 10 minus 5. So just 5 minus k. How much is that? 15 minus 3k. How much is this? 15 minus 3k again. Over here, 25 minus 5. How much is that? 20 minus 4k. 20 minus 4k. Can we take something common? We cannot. Okay, we cannot take something common. All right. So, but this is equal to what? 0. I can write this as 0, 0, 0, 0. So basically, I can compare each of these two. 0. If I compare each of these to 0, what I get? 15. If I take from here, 5 minus k equal to 0. What is the answer? 5 minus k equal to 0 means k equal to 5. K equal to 5. Check in all the places. 15 minus 3k. This should also come as 0. 15 minus 3 times of 5. How much is that coming as? 0. 15 minus 15 is 0. Why this is coming as 0, sir? Because all the elements are 0, no? This with this is 0. Okay. This with this is 0. Alright. So this similarly for this, if you put here 5. 5 into 4 will become 20. 20 minus 20 is 0. Put here 5. 5 into 3 is 15. 15 minus 15 is 0. So yes, k is the value. What value is k? K is the value which is 5, which makes this relation true. Which relation, sir? This relation true. My answer is k equal to 5. Option A. Okay. Quickly, we did. Okay, I hope you understood everything. We got a square using the equation here and simplified it. It is the same equation, okay? Same equation. A square minus ka minus 5i. Why I 2 cross 2? Because same order we have to take to make the subtraction happen. Okay, next question. So A is given as alpha 0 1 1 and B is 1 0 5 1. B is 1 0 5 1. Then find value of alpha for A square equals to B. Means they are saying that this is true. A square equals to B is true. Then find the value of the variable alpha. Then how can I solve this? First find A square. How will A square look like? So A square will look like this. Positive integral of powers for the matrix. So A into A. How much that will look like? Alpha 0 1 1. Alpha 0 1 and 1. Same way here. Alpha 0 1 1. Multiply please. So alpha, first row, first column, so alpha into alpha, alpha square. 0 into 0 is just 0. Okay. 0 into 1 is just 0. Now same thing, alpha into 0 will be 0 and 0 into 1 will be 0. So this is true. Check here. 1, so now second row, 1 into alpha times 1, so alpha plus 1 only, and 1 times of 0 times plus 1, so 1 into 0 is 0, 1 into 1 is 1, so again same thing, what, 0 plus 1. Simplify this, alpha square plus 0, alpha plus 1, 1. This is my a square. They're saying this is equal to b. They're saying this is equal to b. Let's check. So what is b? So they are saying that alpha square equals to, sorry, a square equals to b. So alpha square 0, alpha plus 1, 1 is equals to, this is my a square, right? Correct. Is equals to 1501. Is equals to 15. Correct. So this part is to equal. We can see this is equal. This is equal. So if I compare this over here, 1 second. 1 second. Alpha square, alpha times alpha is alpha square. This is 1 only. This is 1 only. Okay. So now alpha square plus 0. Okay. Alpha. Okay. 0, correct, that's right. Then 1 times of alpha is alpha, 1 times of 1 is 1, 1 times of 0 is correct. So answer is right, alpha square plus alpha by 1. Now this is what, 1051. Something is wrong. Is something wrong? Let's check. Okay. So if I take alpha plus 1 equals to 5, my alpha is coming as 4. Alpha is coming as 4. Okay. And if I take the first two, alpha square equals to 1, then alpha is coming as plus minus 1. How is that possible? So actually plus minus 1 and 4, plus minus 1 and 4. So all these values are correct. All these values are correct. So we are getting two values, alpha equals to 4. So we are getting two values, alpha equals to 4 and alpha equals to plus minus 1. So as you can see, these are inconsistent. Inconsistent means what? Means what? No real values. Means what? No real values. Okay, moving on. Okay, I hope this is clear. Okay, next part, transpose of a matrix. Transpose of a matrix. Simple concept, very simple concept. Okay, what we do here is, sir, the matrix obtained by interchanging row and column. What we do is, by interchanging row and column, okay, is called the transpose of a matrix A. Okay, so if you see here, A is given by ij m cross n. A is given by ij m cross n. So I represents the number of or the position in the row, and J represents column. J represents column. M and n represents again same thing. M is my order with respect to the number of rows, and n is number of columns. So check here. When I'm writing transpose of A, which is A dash, okay, which is A dash, I can write it as J I n cross M. J I n cross M means what is happening? I and J switch the places to J and I, and order which was M cross N became N cross M. So M cross N became N cross M. So M cross N became N cross M. See here. So this is called transpose. Now I can write transpose as A transpose or A power or AT. Okay, both of the representation are correct. So A transpose or AT, both of them are correct, sir. So what happens? The rows and column will interchange itself. The rows and column will interchange itself. So if you check here, this was 2 cross 3. Transpose is getting what? 3 cross 2. 3 cross 2. This was my first row became my first column. Check here, 1 2 3 1 2 3. This was my second row, 205 became my second column, 205. I hope this is clear. The rows and transpose are interchanged like this. Rows and transpose are interchanged like this. So if I am taking an example, so let's say over here A11, A12, A13. I'm trying to take an example of 3 cross 3, which is a square matrix. Okay, order is 3 cross 3. This will be A22, A2. Sorry, forgive me. Not A22, no, A21, A21, A22, A23. And what will this be? This will be A32, again the same mistake, A32, no? So, okay, This will be A31, forgive me. This will be A32 and this is A33. Okay. Now, what did I say? Just transpose or interchange the rows and columns. So this will become, if I'm writing, let's say this is my A. How will my A transpose look like? So how will my A transpose look like? Check here. So the row will become column. So I'll write it as A11, A12 and A13. What about this? Again same thing. A21, A22, A23, correct? The rows are becoming what, bacha? Columns, no? So A11, A12, A13, A21, A22, A23. What about this one? A31, A32 and A33. What is the order of the matrix? Again same thing. There's an important thing to note here. What is that? Is whenever you have a square matrix, you don't have to write everything again. What we do actually in transpose is we take all the rows and write all the rows as columns, and this is our answer. Okay. So but whenever you have a square matrix, do one thing, because think about it. If m and n are same, then even n and m will be same, no? 3 cross 3, if you write like 3 cross 3 or 3 cross 3, doesn't make a difference, right? M cross n and n cross m are same. So this will remain same, the order will remain same. Now what about the numbers? If you see here, A12 was here, it came here, A12 came here, and A21 went over there. So just interchange the places of upper and lower triangulars of the matrix. If you remember, no, upper triangular matrix, lower triangular matrix. So we interchange those position of the elements. Okay. So A12 to A21. Okay, I'm not saying this is upper triangular matrix. I'm saying the elements of upper triangular matrix are interchanged with the elements of lower triangular matrix. So A12 comes to A21. Check here. A12 is here and A21 is there. Same thing goes here. This will come here and this will go there. So A13 has come here and A31 has gone there. Same will go here. So A23 and A32, you can check here, and the diagonal remains same. So for the square matrix, just interchange the places, these two and these two. I hope you understand. Just interchange the places of elements of upper and lower triangular matrix. Okay. Now properties over here. In case of transpose, what properties we have? Check here quickly. So when A and B any suitable matrix, then transpose of sum of matrix, transpose of sum of the matrix will be equal to sum of transpose of the matrix. So either you do the sum first and then try to take transpose, or you take the transpose first and then take the sum, will remain same. Okay. Again same thing. A transpose of A means first you take transpose of A, then again take transpose of A. The answer will be A. Obviously, right? Think about it. If I have, let's say 1, 2, 3 written like this, I take transpose. Let's say this is my A. Then how will my A transpose look like? This will be 1, 2, 3. If I'm asking you to write A transpose the transpose, how will this look like? Again, this will become what? Column will become row. So 1, 2, 3. If you check carefully, isn't that equal to A? Correct, no? So A transpose to transpose is equal to simply the matrix itself. Okay, sir. Now if I have any number k, okay, real or complex, then if it's multiplied to the matrix, if you take it out, does not change it. So whether you write k A transpose or take k out and write it as k times of A transpose. Okay, whether transpose is on k, because k is not a matrix, so it is a number which is multiplied to the matrix. So I can take the k out and write simply the transpose as product. Again, same rule is valid in subtraction also. So if you subtract the two matrices first and they take the transpose, is same as take the transpose and subtraction. So then A transpose minus B transpose, first you take the transpose and take the subtraction, remains same as first do the subtraction and take transpose. So this rule is also true. Now again, what if the sign of the matrix is negative and you're taking transpose? No problem, I can take sign as out. Let's say for example, this is -1, -2, -3. Okay, -1, -2, -3. I can take minus sign common. Okay, if I'm asking to find the transpose of this, you can simply do this as take minus sign common, write 1, 2, 3, take transpose, answer would be -1, 2, 3. So I can take the negative out, take it as common, and then I can write the transpose. Okay, so again, negative of A transpose is same as negative A transpose. Okay. Property 4. Okay. So if I am writing, now this is important. This is important, used a lot in determinant and matrices. So do not forget this. Make it very, very important. Okay. What happens here is, if I have two matrices A and B, okay, such that AB is defined. What is the meaning of AB is defined? Means product is defined. What is the meaning of product being defined? Sir, the number of row in the first matrix has to be same as, so number of column of the first matrix has to be same as number of rows of second matrix. I hope you understand. Okay, column to row. Okay, so yes, correct, no? A M cross N, then B N cross M. So M cross N has to be N cross P, let's call it. So the N and N has to be equal, right? So number of column here should be equal to number of row there. So that's what they mean when they say AB is defined. If AB is defined for any two matrices A and B, then if you're taking transpose of the product, so AB transpose if I'm taking, then I have to do what? I have to do first transpose of B. So if I'm taking AB, the transpose, this has to be equal to, this is equal to, excuse me, first take transpose of B and then multiply that with transpose of A. Why, sir? Because the digits are interchanged, no? Because the order is changed. So this has to be the case. B transpose has to be taken with A transpose whenever you are taking product, the transpose. Okay, first product, then transpose, then the result will be transpose and product will be reversed. So B dash will come first, A dash. I told you, not always AB is equal to BA. Okay, people might say, sir, I can take B dash A, B dash into A dash same as A dash into B dash. So what people can say, sir, I can take B dash into A dash same as A dash into B dash. I said no, not always commutative. The first property of the matrices, not always commutative. So I cannot take this. That's why, remember, write B dash first, then take A dash. Right? B dash first, then take A dash. What is the property? If I am taking transpose of a product of matrix, then the first matrix will come with the transpose first, and then you multiply that with second matrix. Okay. Okay, now same thing can be applied for three matrices. Okay, conformable means what? Again, valid for the product. Three matrices A, B, C are conformable for product means this rule has to be true. M cross N, N cross P, like that for all the three matrices. Means the order has to be in that way. If that is true, means if this is valid, then the property is given like this. A, B, C transpose is same thing. First C will come, then B will come. Basically, C was last here, so C is here. B was next, so B is here. And then A, so A was here. So ABC becomes CBA in transpose. Okay, if you're multiplying it, three matrix, ABC becomes CBA. Okay, I hope you understand this. So you take reversal law. What is this called as? Reversal law. So you reverse it. Very useful, very, very useful. Moving on. Okay, now next question. A and B are given. We have to verify these statements. So let's take quickly here only first. So they are asking to verify A dash. So basically A transpose is A. We can do that, no? So first find A transpose. I said for square matrix, keep the diagonal same. It's a square matrix, no? 2 cross 2. So keep the diagonal same. So 5 and 7 we'll keep as it is, and then we'll interchange these places. So -1 will come here and 6 will go there. Forgive me, 6 will go here. Okay. Now they're saying that transpose the transpose. So A transpose the transpose. How will this be looking like? Same, keep 5 and 7 here, and this will interchange its places. So this will be 6 and this will be -1. Isn't the same thing? Yes, sir. Isn't that equal to A? Check here. A. So first property is valid. Transpose the transpose is same as the matrix itself. Transpose the transpose same as the matrix itself. Now they are saying that do this. A plus B the transpose and A transpose plus B transpose. Okay. Let's do first sum of A and B. Can I do sum of A and B? Yes, sir. Both our matrices are 2 cross 2. 2 cross 2. Let's take sum. A plus B. How will A plus B look like? So 5 plus 2, 7. -1 plus 1, 0. 6 plus 3, 9. And 7 plus 4, 11. This is my A plus B. They're saying transpose of this. They're saying transpose of A plus B. How will that look like? If I have to take the transpose, I'll keep the diagonal same because it is a square matrix and interchange 0 and 9. So this will be 0, this will be 9. This is A plus B transpose. Now they are saying that check whether this is true or not. A transpose plus B transpose. So let's see. A transpose will look like what? I have written it here. 5, 6, minus 1, 7. How will B transpose look like, bacha? Over here, keep diagonal same, 2, 4, and interchange the other numbers, 1, 3. How will that look like? Now add it, A transpose plus B transpose. So 5 plus 2, 7, 6 plus 3, 10, minus 1 plus 1, 0, and 4 plus 7, 11. Check here. 7, 10, 0, 11. 7, okay. 6 plus 3, no? A mistake from my side. 6 plus 3 is 9, not 10, okay? So 6 plus 3 is 9. So 7, 9, 0, 11. 7, 9, 0, 11. So be careful in the addition. Things are very easy. So sometimes you get to get ahead of your what you're thinking of your plan. So make sure that you are calm there and make the calculations without any mistake. Okay, make the calculation without any mistake. So 3 plus 6 is 9. Okay, 7, 9, 0, 11. So this is true. Sum you take first, and then you take transpose, or you take the transpose first and then you take sum. Answer is same. Now same, I think you can check this. So you can take this as homework. Please verify. Please verify. What are you going to do? Take the subtraction first and take the transpose same way. Take the subtraction first and take transpose, get some result, and then take the transpose and then take subtraction. So first take transpose and then take subtraction. I hope this is clear. I hope this is clear. Okay, sir. Moving on. Okay, that I kept for solving this last part, but I want you to solve it. Okay, and say, sir, that for the question number 5, part 3 is verified. Is verified. I just don't write it in the comments. Sir, it is verified. Solve it. Okay, solve it and then write. Sixth one. They're saying that find A transpose. So I have to find A transpose. No, let's find A transpose first. Is it a square matrix? Yes, sir. 2 cross 2. Yes, sir. 2 cross 2. Keep the diagonal same. I said no. For square matrix, keep the diagonal same. So this will be my cos x, and this will also be my cos x. What about this interchange? Minus sign will come here, minus sin x, and this sin x will go up. So we are taking care of a matrix which is not a number, just a function, Okay, sir. So what are they asking? Multiply A with A transpose. A with A transpose. Order is very important, bacha. Don't take what people or students do know. They'll take A transpose first. They'll read this question once in hurry and take A transpose into A and get some answer will be wrong. Make sure that you're getting A and A transpose. Okay? Okay. In this case it will not matter, but still you do this way. In any question you're getting, you make sure that you are doing this way only. Okay, sir. Okay, sir. In this case it does not matter, but in other cases make sure that you are looking at the question properly. Okay, let's see. So A into A transpose. First write A. What I'm doing. A is cos x minus sin x. Cos x minus sin x. And this is just sin x and cos x. What is my A transpose? This part. Cos x sin x. Okay. This is minus sin x over here and cos x. And cos x. This is clear? This is clear? Okay, sir. Okay, sir. Okay. Now do the multiplication. Do the multiplication, please. So first row, first column. So this will look like this. Cos x into cos x. So cos square x minus sin x into minus sin x. So plus sin square x. Correct, no? Okay. Now this with second row. So cos x into sin x. How much that will be? Cos x sin x. Okay. And then what? Minus sin x into cos x. So minus sin x cos x. Okay. Next what? Second row with the first column first. Okay. Okay. Yeah. So cos x into sin x was cos x sin x, and minus sin x into cos x was minus sin x cos x. Okay, sir. Now we'll do second row. Sin x into cos x. So there will be what? Sin x cos x and sin x into cos x into minus sin x. Second element, right? So minus sin x cos x minus sin x cos x. Second, same thing. Second row with second column. Sin x into sin x will be sin square x and cos x into cos x will be plus cos square x plus cos square x. What is the result? Check the result here. This is 1, this is 1. Identity, sin square x plus cos square x is 1. This is 0. Cos x sin x minus sin x cos x, 0. Sin x cos x minus sin x cos x, again 0. Sin square x plus cos square x, again 1. What is the answer? 1 0 0 1. 1 0 0 1. So this is 2 cross 2 matrix and this is identity matrix, right? Only diagonal element are 1, rest all is 0. So I can write this as I2, no? I2, option is 2. Option is B. So identity matrix with order 2. Order 2. Okay, square matrix, so that's why I2 is correct answer. Okay, this one, A power 16 we have to find out. A power 16. Okay, let's see. A is given. You have to figure out A power 16 is one of these options. Let's see what is it. So before going to A power 16, what is this question from? The positive integral powers of matrix. Okay, positive integral power. No, 16 is the positive integral. Correct. So before going for A power 6, let's write it as A into A first. What is A into A? A square. A into A is A square. So how will this look like? A into A I have to do. So 0 0 x 0. Okay, multiplied with 0 0 x 0. Please do the multiplication here. First row, first column. So first row is 0 0. So I'll get 0 plus 0. Second first row, second column, again 0 plus 0. Now this one, x times 0 will be 0 and 0 times x will be again 0. Over here, x times of 0 will be 0 and 0 times of 0 will be 0. What is my answer? 0 with what? What is the order? Let me write completely only. Why to skip any step? So this will look like 0 0 0 0. So what is the order? 2 cross 2. So I can write this as 0 2 cross 2. 2 cross 2 or just 2. Okay, this is my A square. Now what is A16 going to look like? So A16 will be looking like A square power 8, I guess. Power 8. So 0 power 8 will be what? 0 only, no? 0 only, right? Answer is D. Simple question. Hope you understood. 0. A square is coming as 0. Anything you take power to that will be 0 only, no? So answer is 0 or null matrix. What is it? Null matrix, sir. Of what order? 2 cross 2. Of order 2 cross 2. Okay, moving on to this question. Okay. Looks complicated, but might be easier. We'll solve it to see it. Cos square sin theta cos theta. Cos square sin theta cos theta. Cos theta sin theta. Okay. And sin square theta. And then B is given as phi cos square phi sin phi cos phi. Cos phi sin phi sin square phi. Okay. So first expression is given in terms of theta. Second matrix is given in terms of phi. We'll do the multiplication. Can you do it here? Not enough space. Let's do it over here. So help me write the expression first. So cos square sin square is my diagonal. And what is my other elements? Cos theta sin theta. So let me write it as A. Write it here as A. What is it? It was cos square theta. Here also I think sin square theta. And other was cos theta sin theta, I guess, at both the places. This was cos theta sin theta. Over here also cos theta sin theta. Please cross check. Cos square sin square, cos theta sin theta cos theta. Correct. So same thing. Now same thing goes here. Cos square sin phi, cos square sin square phi, and this remains same. So let's write for B also. This is cos square phi. This is cos phi sin phi. This is again what? Cos phi sin phi, and this is what? Sin square phi. Let's cross check once before moving on. Correct. They are asking that they are saying that, not asking, they are saying that this is true. AB is equal to 0. It means whatever you get the product after, whenever you do the multiplication, the result is equal to 0. So let's do the multiplication. AB. How will AB look like? This will be little bigger. this will be a little bigger. So why not take some more space? Okay, if I'm doing for AB, forgive me, just AB, I think this will be enough. Okay, so just AB will look like this. First I will take what? First I will take this, sir. First row with first column, first row with first column. This is going to be my first element, right? So cos square theta with cos square phi. So I get cos square theta and cos square phi. Okay, then this part, cos theta sin theta and this. So I get plus cos theta sin theta and then cos phi sin phi. Then cos phi sin phi. This is my first one. This is my first one. Okay, I hope you understand. Check here. So cos square theta with cos square phi and then cos theta sin theta with cos phi sin phi. Cos phi sin phi. Okay, sir. Next what? Same we will do with second row. Same we'll do with second row. Check out here. So this will look like cos square theta with this. Cos square theta with this, so it will be cos square theta cos phi sin phi, cos phi sin phi, and this will be what? Cos plus cos theta sin theta, sin theta not sin phi, sin theta, okay, okay, sin theta, sin theta, sin theta with sin square phi, with sin square phi, sin square phi. So first row with second column is also done. So cos theta, cos square theta cos phi sin phi and cos theta sin theta with sin square phi. This is done, bacha. Okay, sir. Okay, little bit calculated, little bit complex, so we can solve it. Still we can try to do something over here. Cos sin with now what? Second row with my both the columns. So cos theta sin theta over here you check. So cos theta sin theta with this part cos square phi, and this again sin square theta with this part plus sin square theta with cos phi sin phi, cos phi sin phi. Now we go with the second column. So cos theta sin theta with this part cos theta sin theta, okay, with cos phi sin phi, cos phi, and I'll write here sin phi plus what? Sin square theta with sin square phi, sin square theta with sin square phi. Okay, this is my last element, correct? This is my last element. This is in the product only. This part is in product only. I hope you understand. Okay. Now if you check here, what is the condition given here? The condition given is AB equals to 0. The condition given is AB equals to 0. If I check here, then what I get? This should be, this entire thing over here, AB would be equal to 0. It means the first element has to be equal to 0. Okay. All element has to be equal to 0, but if I take only first element, just to consider this case, because we are trying to reach the result for theta and phi, okay. So in that case, I can get that result from here only, from the first element only. Means the element 1 has to be 0 because the product of A and B is null matrix. The product of A and B is null matrix. Okay, sir. Okay, sir. So write A and B. So this part. So basically what I'm trying to say is cos square theta times cos square phi plus cos theta times sin theta into cos phi times sin phi. This whole thing is equal to 0. Correct? Now something is common. Cos theta sin theta. Sorry, cos theta cos phi. Cos theta cos phi. I can take it common, bacha. So cos theta cos phi. Common here. What is left in the first term? Cos theta plus cos, sorry, not plus, It's product, right? It's product. Okay, sir. Cos theta, cos phi is left in the first term. For the second term, plus sign, only sin theta and sin phi is left. And sin phi is left. Okay, sir. Okay. Now check here. Check here. If I'm continuing from here, so it will become cos theta, and this would be equal to what? This would be equal to 0. Cos theta, cos phi, and what about this? Cos theta, cos phi, sin theta, sin phi with a plus sign. Cos A, cos B, sin A, sin B. Cos of A minus B. Cos of A minus B. So this will become cos of theta minus phi. Theta minus phi. Theta minus phi. Okay. Sir, why not phi minus theta? Same thing, bacha. For cos, it's same thing, right? Whether you take theta minus phi or phi minus theta, it's same thing. Okay. So cos theta minus phi, from the formula cos A, cos B, sin A, sin B is the plus sign. So cos theta minus phi. Now check here. These two cannot be 0. These two cannot be 0, right? This 2 cannot be equal to 0. Means what has to be 0? If a product is 0 and the two elements are not equal to 0, it means that the third element has to be 0. Third element has to be 0. So we'll get it as cos of theta minus phi equals to 0. When is cos 0? Cos is 0 as odd multiple of pi by 2. Cos theta is 0 at odd multiple of pi by 2. Basically, theta minus phi, the angle, this has to be odd multiple of pi by 2. How I write odd number? 2n plus 1. 2n is even, 2n plus 1 is odd. Multiple of pi by 2. Okay, I'm trying to write for theta. So theta will be equal to what, bacha? 2n plus 1 times pi by 2. And phi will come here and become positive, plus phi. Plus phi. Check your options. Check your options. Check your options. Yes, I think option C is correct. Option C is correct, is it? Phi plus 2n plus 1 pi by 2. Phi plus 2n plus 1 pi by 2. 2n plus 1 pi by 2. Option C is correct. For n belongs to 0, 1, 2. For n belongs to 0, 1, 2. Okay, I hope this is clear. Okay, next question. This was clear, right? Theta equals to, the phi was negative here, goes there, becomes positive. So theta equals to 2n plus 1 pi by 2. This is my final answer. Okay, this is my final answer. Option C was correct. Option C is correct. Okay, moving on to this question. What is it? P is given as, this matrix is given as P. This matrix is A, and they're saying that Q is another matrix which is equal to PAPT, which is equal to PAP transpose. Then find the value of P transpose times Q to power 2005 times P. Okay, Q to power 2005 times P. Okay, can we find Q value? Can we find Q value first? So basically, if I multiply P with A and P transpose, P with A with P transpose. Okay, all right, sir. Let's check here first. Let's check here first. Let me write the values of this. Okay, okay. Write the value of this, sir. We'll do in the next slide only. Q equals to PAPT. Q equals to PA P transpose. One thing. Second thing is A is 1101. A is 1101. Okay, and they are looking to what? They are looking to find P transpose Q 2005 P. P transpose Q 2005 P. Okay, if I have to put the value of Q here from here, how will this look like? Check here. So it will look like P transpose times what? I can write this as PA P transpose. Okay, to power how much? To power 2005 times P. Correct? Correct? Okay, sir. Okay, sir. Now check here. P transpose, I can write P here. This 2 I'm clubbing. Now I'm keeping A as it is. I'm keeping A as it is. Okay, sir. And then I'm writing what? Again, P transpose. But how many times I have to write like this? Check here. You have to write the expansion for this. If I don't write like this and write the expansion, how will that look like, bacha? This will look like this. P A P transpose P A P transpose. So many times, how many times? Last will be PA, P transpose, and this will be my 2005 times. What is it? 2005 times P. Okay. Now see, I can club something together. P transpose times P, P transpose times P, and same will keep going like this, and this with this. Okay. So what I'm left is P transpose into P will be what? Identity. Identity all the time. So identity times what? What? I will have just A left. Multiplied how many times I will multiply A with? So 1 time, 2 time till 2005 times. So A power 2005. A power 2005. Let me explain again. P transpose times P is identity. Again this identity, this identity. So every time we are getting this, P transpose into P is identity. So that is just I. I into I into I into I is I. Okay, what about A? I have A left with this A, with this A, and how many times? 2005 times. 2005 times. So the power of the A will be 2005. Power of A will be 2005. Okay. So if I find, basically they were asking us to find this, and we said that this is equal to A power 2005. A power 2005. So if I can find that, if I can find A power 2005, that's my answer. Okay, let's find A square first. A square is going to be what, bacha? A into A. So A will be what? Let me write the matrix straight away. A will be what? A will be 1101, 1101 with 1101. Let's do the multiplication, please. So 1 times 1 will be 1, 1 times 0 will be plus 0. Okay, next what? 1 times 1 will be 1, and 1 times 1 will be plus 1. I am doing this with this now. Okay, done. 1 plus 1, 1 plus 1. Okay, 1 plus 1. What about this? 0 times 1 will be 0, and 1 times 0 will be again 0. This 0 times 1 will be 0, and 1 times 1 will be again 1. What is my answer? A square is nothing but 1201. 1201. Okay, sir. What about A cube? What about A cube? I can write this as A square times A. Okay, A square times A. A cube is nothing but A square times A. What is my A square? 1201. And what is my A? Same thing, 1101. Do the multiplication, please, again. What's the multiplication? 1 times 1. First row, first column. 1 times 1 and 2 times 0. So 0. 1 times 1 and 2 times 1. So plus 2. Over here, 0 times 1. 0. 1 times 0. 0. 0 times 1. 0, and 1 times 1, 1. Answer is what? Answer is 1301. Can you see a pattern here? If I am writing A power n, this will look like, see, first term is keeping same. Okay, give me 1 second. First term you see here keeping same all the time. A square also same thing. A also was same thing. Okay, so first term is 1. First term is 1. Second term is keeping as, if I am finding cube it is 3, for square it is 2. It means for power n it will become n, and these two terms are also keeping same. So if I am finding A power 2005, answer would be what? 120501. Which is what? Which option? Check here. Which option? Option A is correct, I think. Option A is correct. Only this element is changing. 2005, rest is 10101. Option A is correct. Option A is correct. Let's move on. So we use Q in the expression that they were asking. This was the expression they were asking. Use this, the formula of the property of P transpose P to get the identity, and simplified it using positive integral of a matrix. Okay. Okay. Moving to the next question. Okay, sir. A is cos alpha, sin alpha, minus sin alpha, cos alpha. We have to find A power 10. We have to find A power 10. Similar question. Let's do it quickly again. Same thing, no? The index is what? In this case, 10. Okay. So cos alpha, sin alpha, minus sin alpha, cos alpha. Let's do it here. A is given as cos alpha, sin alpha. What is next? Minus sin alpha, cos alpha. Minus sin alpha, cos alpha. Okay. So before we go ahead and find A power 10, let's quickly find A power 2. It's correct, no? Cos sin minus sin cos. Cos sin minus sin cos. Correct, sir. So let's find quickly A square before going into anything else. A square will look like what, bacha? A square will look like, same thing, we have to multiply it itself. So cos alpha sin alpha minus sin alpha cos alpha multiplied with itself. Same thing. So cos alpha sin alpha minus sin alpha and cos alpha. Correct? Correct. Let's do the multiplication. Cos into cos. Cos square alpha, this into this. Next was sin into sin, minus sin square alpha, minus sin square alpha, correct? This into this. Okay, next what? Cos into sin. So this will be what? Cos alpha, sin alpha. What next? Sin into cos. So plus, same thing, sin alpha, cos alpha. Okay, okay, let's check here. Now second row, sin alpha with cos alpha will become what? Minus sin alpha, cos alpha, minus sin alpha, cos alpha, and then what? Cos alpha with sin alpha. Okay, sin alpha with cos alpha is this, and cos alpha with minus alpha is same thing. So minus sin alpha and cos alpha. I'm doing this with this. Done, sir. Now do this with this. Cos alpha into sin alpha. Cos into sin alpha will be how much? Sorry, this from here, no? Sin alpha into sin alpha will be minus sin square alpha. The negative sign is here, so minus sin alpha into sin alpha is sin square alpha, and cos alpha into cos alpha is plus cos square alpha, plus cos square alpha. Okay, sir. This will become what? Cos square theta minus sin square theta. Formula, remember? Cos square theta minus sin square theta. What is this? Cos 2 theta. Cos 2 theta. So this will be cos 2 alpha. What about this, sir? Cos A, sin A, cos A. Okay. What is this? 2 sin A, cos A. So basically what? Sin 2A, not theta, alpha it is. It is what? It is alpha. Okay. This formula is okay. This is alpha, bacha. This is alpha. Okay, sir. So cos 2 alpha, sin 2 alpha. Over here, I can take minus sign common. It will become sin alpha, cos alpha, sin alpha, cos alpha. Again 2 sin alpha, cos alpha. Correct. Now if I take this common, this will be 2 sin alpha, cos alpha only, no? 2 sin alpha. If I take minus sign common, this and this will become plus. Okay. I don't have to just add this. Don't have to take common also. So what will this become? Simply minus sin 2 alpha. Minus sin 2 alpha. What about this? Check here. Cos square alpha minus sin square alpha. Same formula. So cos 2 alpha. Cos 2 alpha. This is my a square. This is my a square. What about a cube? What about a cube? So a cube will look like this. A square into a. A square into a. Correct? A cube is a square into a. Okay. So what we are trying to do here? We are trying to reach the general formula. Means what is this going to be? What is a power n going to be? So if I know a power n expression, I can put n as 10 and get our result. I can put n as 10 and get our result, right? That's what we are trying to achieve here. We are trying to achieve a power n, okay? I hope you understand. I hope you understand. A cube will be a square into a. So what is my a square? This part. Cos 2 alpha sin 2 alpha minus sin 2 alpha cos 2 alpha. Okay, my sin 2 alpha cos 2 alpha. Now what is going to be my a? Same thing I'll write here from here. Cos alpha sin alpha, over here again minus sin alpha and cos alpha. Minus alpha and cos alpha. Okay, now last part we are doing what? Multiplication of this and this. How will it look like? How will it look like? Check here, bacha. So this cos 2 alpha with sin alpha will do first. So this will be cos 2 alpha cos alpha. Okay, then what? Sin 2 alpha minus sin alpha. Sin 2 alpha sin alpha. Okay, minus sin, because this is positive, this is negative. Next what is going to be? Next is going to be the same thing with sin and cos. So this will look like what? I'm writing the second term below. So cos 2 alpha into sin alpha. So cos 2 alpha into sin alpha with sin 2 alpha into cos alpha plus sin. Sin 2 alpha into cos alpha. Okay, this is my first and second term. First and second term. I hope you can understand this. I hope you can understand this. Okay, let's quickly check here for the next part. Second column we're going to take now. Second row we're going to take now. Second row we are taking. So minus sin 2 alpha with cos alpha sin alpha. So cos alpha will be what? Like this, minus sin 2 alpha and cos alpha. Same thing here, cos 2 alpha with this, so minus sin alpha cos 2 alpha. Okay, last term, so minus sin 2 alpha with this. I'll write it here below. I hope you can understand. This I will multiply with this part. So minus 2 alpha with sin alpha. So minus sin alpha sin 2 alpha. Okay, and check here, cos 2 alpha into alpha. So plus sin. So cos 2 alpha into cos alpha. So plus sin cos 2 alpha into cos alpha. Now we have to figure out this expression. How will this look like? Check here. Now check here. Last step, very important. We're going to use the compound angles a plus b and a minus b formula. So cos a cos b, sin a sin b. Listen to me carefully. A cube I am trying to get. Cos a cos b, sin a sin b means cos of a plus b. Cos of a plus b, what is that going to be? 2 alpha plus alpha. So 3 alpha. Remember, I'll write it here if you want me to. Cos a sin b and sin a cos b, sin a cos b, sin a cos b. So this will be, sorry, sin a sin b. This will be cos a cos b, sin a sin b with a negative sign. Cos a plus b, which is 2 alpha plus 3 alpha. 2 alpha plus alpha will be 3 alpha. Okay sir, okay sir. Next part over here, cos 2 alpha sin alpha means cos a sin a and sin cos a sin b. This is alpha, right? So cos a sin b and sin b cos a. Basically what? Sin a plus b. Sin of a plus b. So 2 alpha plus alpha, again 3 alpha. Okay. Now you can take minus sign common here. Now look at this. Sin a cos b, cos a sin b. Sin, this is my a, this is my b. So sin a cos b and cos a sin b with a minus sign. I taken minus sign common. So it will be what? Sin simply a plus b. Sin a plus b will be what? 3 alpha. Okay, what I'm getting here? Same thing. Okay, same thing. Over here, this is minus sign. This is minus sign. Okay, so cos a cos b, cos a cos b, sin a sin b. This is simply what? Cos of a plus b. So 2 alpha plus alpha, which is 3 alpha. 3 alpha. Okay. Now check here carefully. Check here. When it was 3, it is coming as 3, 3, 3, 3. When it is 2, it's coming as 2, 2, 2, 2. So if I'm writing it for n, if I'm writing for n, how will that look like? How will that look like? So a power n will look like this. Cos n alpha, cos n alpha. Okay, check here. Cos n alpha, sin n alpha, cos n alpha, sin n alpha. 1 second. Let me raise this last part. Sin n alpha. Okay. And what is the next part? Oh, sorry. Minus sin n alpha, minus sin n alpha with cos n alpha, with cos n alpha. So this is it. Check here. Everything remains same. So cos is cos, sin is sin, sin is with the negative sign, and cos is cos. Only n is extra part. Only n is coming here. When the index is n. When the index is n. So in this case, what they were asking, index is 10. Index is 10. So we'll take the same thing with power 10. So it will become what? 10 alpha, 10 alpha, 10 alpha, 10 alpha. So look for it. Cos 10 alpha, sin 10 alpha, where only sign is negative. Okay. Cos 10 alpha, sin 10 alpha, minus sin 10 alpha and cos 10 alpha. Option B is correct answer. Option B is correct answer. Check here. Option B is correct answer. N is what in this case? If I'm writing for a power 10, n will be what? N is 10. So wherever I have n, I'll replace that n with 10. I'll replace that n with 10. Over here also 10. Over here also 10. Over here also 10. So I get what? 10 alpha, 10 alpha, 10 alpha, 10 alpha, and cos sin minus sin cos. Cos sin minus sin cos. Option B is correct. Option B is correct. Let's move on to the, look at this option. Okay. Let's move on to the next problem. We got the previous one right. Okay. Yeah. Okay. Okay. So now this question. I think last problem of the day. Last problem of the day, sir. Simple question. Simplest of all, but smart problem. Simplest of all, but smart problem. A is given like this. B is given like this. Again, both are matrices of same order. Don't say how, sir. 2 cross 2. 2 cross 2. They are asking us to find a power 8. A power 8. Okay. Can you see a similarity? Can I write, if I write if I write A equals to IB, is it correct? Is it correct? Check. If I multiply I with B, I times 1 is just I, which is A only, minus I times, so what I'm trying to say here is, check here, B, 1 minus 1 minus 1, 1. Multiply here. I with 1 will become what? I with minus 1 will be minus I with minus 1 will be minus I, and I with 1 will be plus I. So what is it? I minus I minus I minus I minus I. Same thing, no? This is A only, right? So I can write like this, no? A equals to IB. It's correct only, no? It's correct only, no? So let me just erase this part. I don't need it. I wanted to show you that it's true, that A equals to IB is valid. Okay, sir. Alright. So if I do, I need to take the squares and powers of 8. So let's do A square first. I get what? IB the whole square, nothing but I square B, nothing but B square, I square B square, nothing but minus 1 times minus B square. Okay, what is my B square? Check here. I know B, right? So B square is nothing but B into B. B into B. What is B into B? Do this here, multiplication. 1 minus 1 minus 1, 1 with itself. 1 minus 1 minus 1, 1. Let's do the multiplication, please. If I do that, what I get? A 1 into 1 is simply 1. Minus 1 into minus 1 is again 1. Okay. So I am doing what I'm doing here. I hope you know by now. First row with first column. Okay. So 1 plus 1 over here. Minus 1, again minus 1 over here. Minus 1 with 1 is minus 1, and 1 with minus 1 is again minus 1. And this with minus 1 is plus 1, and 1 with 1 is plus 1. What is my answer? Check here. So answer is coming as, so my B square is coming as 2 minus 2 minus 2, 2. So basically I can take 2 common and write it as 1 minus 1 minus 1, 1. So basically what is it? It's 2B, no? This is B only, right? 1 minus 1 minus 1, 1. So basically my B square is 2B. So I can write A square equals to minus 2B. Please check. Please check. Please check. From here, A square is equals to what? Minus B square from here. So from here I can write B square as 2B. So minus 2B. Again take the power 4. So A square the power square. How much that will be? A power 4. A power 4. How much is that going to be? Minus 2B the whole square. Minus 2B the whole square. Correct? Minus 2B the whole square. So this will become what, bacha? Plus 4B square. Plus 4B square. Correct, right? Correct, right? A power 4 will be minus 2B the whole square, no? If I am squaring both sides. So 4B square. Again B square is what? B square is 2B. B square is 2B. So this becomes what? 8B. 8B. What is this? This is A power 4. This is A power 4. A power 4 is 8B. A power 4 is 8B. Check here. A power 4 is 8B. Now what are you looking for? A power 8. So I can write A power 8 as A power 4 the whole square. So this will come as 8B the whole square. So this will come as 64B square. B square is nothing but 2B. See here, 2B. I can write this as 64 into 2B. 64 into 2B. 64 into 2 is what? 64 into 2 is what? This is 128 times B. 128 times B. Option B. 128B is my correct answer. Okay, I hope you understood this. What I did, I took A, I expressed A in terms of B. Why that? Because I want to find A8. Means, and I have to get results in terms of B only. So I have to write A in terms of B. So I wrote A terms as A equals to IB. Squared it up, simplified it to get B square equals to 2B. Using the expression A square equals to minus B square, and simplified again forward as 128B for A power 8. I hope this is clear. I hope this is clear. Okay, so this was it for the session of multiplication of matrices. I hope I have not made any mistakes, but if I have, make sure that you correct it. Comment below if I have made any mistake. I'll cross check it. I'll reply to you. But this was it. The session was very engaging. Okay, a lot of questions we have done. Almost I think 11 problems we solved on each category. On solved on transpose, multiplication of matrices, properties of multiplication, and properties of transpose as well. So make sure that you solve all the questions. If you're not able to solve with me, take a pause and make sure that you solve all the problems without missing anyone, okay? And otherwise you can watch the entire session and then solve questions one by one, okay? I hope this is okay and this is a good session. We'll again be coming up with the next session for matrices. In this session we'll discuss about inverse of a matrix and other things, okay? So that's all for today. Keep smiling, keep working hard, and I'm signing off from here. Take care and bye-bye.